Welcome to The Explainer. Today, we're diving into a really wild idea. What if our reality isn't just described by math, but is actually made of math? I'm talking everything, from the coffee in your cup to the most distant stars.
So, let's just jump right in with a huge question, one that physicists and philosophers are actually wrestling with. It's a question that totally flips our basic understanding of existence on its head.
And this all circles back to a mystery that even stumped Einstein. He called it the unreasonably effective nature of mathematics. I mean, think about it. How is it that some equations scribbled on a blackboard can predict the existence of a whole planet, like Neptune, or something as elusive as the Higgs boson, decades before we ever actually see them? How can abstract thoughts map onto physical reality so perfectly? It's kind of spooky, right? Well, this idea that the universe has a mathematical secret at its core, it's not as new as you might think. It's actually a concept with a really long and fascinating history. I mean, we're talking way back. From the ancient Greeks like Pythagoras, who saw numbers in everything, from the harmony in music to the planets moving across the sky. And this idea, it's just kept evolving for centuries, from a philosophical hunch into a full-blown modern scientific hypothesis, thanks to guys like Tegmark. This brings us to a huge debate in the world of math and philosophy. Is math something we humans invented, or is it something we discovered? You know, the formalists say we made it up. It's just a useful game with symbols and rules, kind of like chess. It only exists in our heads. But then you have the Platonists, who argue that math is an objective reality that exists out there, completely independent of us. We're not inventors. We're more like explorers, discovering these timeless truths. And as you're about to see, Tegmark's theory plants its flag firmly on one side of this debate. So let's get into it. MIT physicist Tegmark comes along and offers a pretty startling answer to this whole unreasonably effective puzzle. And believe me, it's an answer that could turn our entire idea of reality completely upside down. He calls it the mathematical universe hypothesis, or MUH for short. And let's be super clear here. This is not a metaphor. He's not saying reality is like math. He is saying that our external physical reality, you, me, this planet, everything, is, quite literally, a giant mathematical object. Okay, so what does that even mean? Well, think back to that unreasonably effective problem. If the universe is a mathematical structure, then the mystery just vanishes. It's not unreasonably effective at all. The analogy on the slide is perfect. It's like using the word apple to describe an apple. The description fits perfectly because the thing you're describing and the language you're using are actually one and the same. But hang on, because this idea doesn't just stop with our own universe. Nope. It logically leads to an even more mind-bending concept, the multiverse. And Tegmark has this really neat way of organizing it into 4 different levels. Okay, so check this out. Each level here gets progressively weirder. Level 1 is the idea that space is infinite, so somewhere out there, far beyond what we can see, there are other regions just like ours. Most cosmologists are pretty on board with that. Then you have Level 2, which comes from ideas about the Big Bang. It suggests there are other bubble universes out there, each with totally different physical constants. Level 3 comes straight from quantum mechanics, the idea that every possible outcome of an event actually happens, creating a new parallel world. But Level 4, that's the big one. That's the ultimate conclusion of this whole hypothesis. It's the idea that any mathematical structure that is self-consistent exists as its own real universe. And this, right here, is the absolute core of the hypothesis. You can think of it like this cosmic library. Our universe, it's just one book on a shelf. A really, really complex book written in the language of quantum physics. But on that same shelf, there are other books describing completely different universes, written in totally different kinds of math. And the rule of this library is simple. If the math is consistent, if the book makes sense on its own terms, then the universe it describes is real. It physically exists somewhere. All right, so if we're living in this vast mathematical reality, maybe just one of an infinite number of others, what does that do to some of our most deeply held beliefs? Let's talk about the big ones: God, time, and free will. So in this picture, God isn't some personal being, a man with a beard on a cloud. God is the total, all-encompassing mathematical structure of everything. It's the blueprint that contains all the rules, all the truths, and all possible worlds. which is kind of a cool idea, right? It means that when a physicist is studying the laws of nature, they're essentially practicing a form of theology. They're trying to understand this grand eternal structure. And what about time? Well, that feeling we have of time flowing like a river, it's an illusion. In this mathematical view, time is just another dimension, like length or width. The past, present, and future, they all exist simultaneously. Our entire history is laid out like a static, four-dimensional block. Our consciousness just experiences it slice by slice, kind of like a spotlight moving along a film strip that's already been printed from beginning to end. So what does that mean for free will? When you make a choice, say between coffee and tea this morning, you're not actually creating a single path forward. Instead, that moment of choice is where reality itself branches. In one reality, a version of you is drinking coffee. In another, equally real branch, a different version of you is drinking tea. So your choice is really just your consciousness experiencing one of those pre-existing paths. Wild, right? Okay, obviously an idea this huge and this strange isn't going to fly without some serious pushback. And the mathematical universe hypothesis faces some major challenges both from scientists and philosophers. First off, the big one. It might be completely unfalsifiable. I mean, how can we ever test for the existence of universes that are based on different mathematics if, by definition, we can never interact with them? That kind of pushes the whole idea out of the realm of science and more into philosophy. Then there's what some call the baggage problem. If all mathematical structures are real, why do we find ourselves in this one? Why this universe with all its beautiful complexity, and not some much, much simpler one? And maybe the toughest nut to crack is the hard problem of consciousness. How can a bunch of abstract equations and numbers generate the rich, subjective experience of what it's like to taste chocolate or fall in love? The theory just doesn't have a good answer for that. Yet. Now, at this point, you might be thinking about something you've probably heard of, the simulation hypothesis. You know, the idea that our whole reality is just a super advanced computer simulation. It feels kind of similar, doesn't it? So how does it fit in with all this? Well, what's interesting is that the mathematical universe hypothesis is actually even more fundamental. Think about it. A computer simulation is, at its core, just an algorithm, right? A very specific type of mathematical structure. So if we are living in a simulation, we're still living in a mathematical universe. The simulation hypothesis is just one possible flavor of the MUH. The huge difference, though, is that the MUH says you don't need a computer to run it on, and you don't need a programmer to write the code. The math just is. It's the fundamental reality itself. And so that's where we're left. It's a massive question. Is the incredible world we see around us just one self-aware piece of a vast, timeless mathematical object? Or is math simply the best tool, the most powerful language we humans have ever invented to make sense of a reality that's ultimately something else entirely? The answer, whatever it is, really defines not just the universe, but our very place in it. So what do you think?